Alright, for this section, I'm not going to fill in all of the vocabulary. It's kind of like in your own words to help you memorize this stuff. Alright, so I'm going to draw a picture for this one. And I'm going to draw an inscribed angle. So the big thing for the inscribed angle is that the vertex is on the circle. Okay? The intercepted arc is the part that the angle cuts into, right? So like if I had said the angle stops here and stops here, that's the intercepted arc. Okay? This subtend, not so important. Okay? An example. If I had this picture here, and I labeled this arc out here 70 degrees, then the measure of angle B would equal half the measure of AC, because AC is the intercepted arc. So I would fill in the measure of angle B equals half of 70. So the measure of angle B is 35. Alright, we're going to go down like inscribed angle theorem, inscribed angles of a circle theorem. This all goes together, so we're not drawing more examples here. What is an inscribed polygon and what is a circumscribed polygon? An inscribed polygon just means that the polygon has vertices that are all on the circle. Okay, all the vertices are on the circle. And the polygon's inside. When it's circumscribed, it means the circle's on the inside and the polygon touches the circle at one point. Okay, so the circle's on the inside if the polygon is circumscribed. And this one's kind of hard to draw. It would just look like that. Again, it's just a vocabulary word. It's not super important. Inscribed right triangle theorem. So, if there's a right triangle in a circle, the side has to be the diameter, because this is 180 degrees, which makes this angle 90 based on the fact that it's inscribed. Okay, the angle is half the arc. So if I had a problem where I had, let's pretend that's a diameter, let's pretend I drew that nicely, like this, and I knew that this was 25 and this is my x, then I'd have to see that this was 180, which makes that 90. So I'd know 90 plus 25 plus x has to make 180, because triangles make 180 degrees. So I'd add up what I know. So I have 115 plus x equals 180, and then I subtract the 115 from 180. So I have 65. Alright, inscribed quadrilateral theorem. Inscribed quadrilaterals. The opposite angles are supplementary. Supplementary means they add up to 180. So in this picture, x plus y would equal 180 because those are opposites, and a plus b would equal 180 because those are opposites. Alright, now let's look at the problems that go with these notes. So This one says find the measure of DEF. So that's right here. I'm going to put a little X there. This angle intercepts this arc. This vertex is on the circle. So we're going to say the angle is half the arc. So our missing angle is 50. That angle is DEF 50 degrees. These congruency marks on this chord and this chord tell us that this arc and this arc are the same measure. If I have this full circle here and these three arcs make up that full circle, I'm going to take away what I know, which is the 100, and then these are equal, so I'm going to split that in half. So this is 130 and this is 130. So measure of arc ED is 130. For number 2, this angle is 87. It stops at B and at C. BDC is this angle. It also stops at B and at C. So the intercepted arc is the same for both angles. When the arcs are the same, the angles are the same. So this angle is 87. That 27 didn't mean anything. Okay. Number 3 is an inscribed quadrilateral because all of these vertices are on the circle. We're going to say that the opposite angles are supplementary. 4x plus 5x equals 180. Put our like terms together and then divide by 9. So x is 20. E and G would also be supplementary. So I'm going to add those together and they equal 180. I combine my like terms and then I add 18 to each side and then I divide. 198 divided by 11. 18. Number 4, determine whether AB is a diameter. Explain your reasoning. Well, if this is 120 and this is 30, this is inscribed, that would make this 60 because the angle is half the arc. Together, 60 and 120 make 180. So if they make 180 together, it's half the circle. The diameter splits the circle in half. So yes, AB is a diameter because what I said, the measure of ACB is 180. Alright, number 5. We have an inscribed angle. That means this angle is going to have to equal half of the arc that goes from E to F. I know that this is 45 and this is 131. So if I add those up and take them away from 360, I'll be able to figure out what my missing arc is. These add up to 176. If I take that away from 360, I'm left with 184. So the measure of angle D is half of 184, which is going to be 62. Alright, for the next one, number 6, this angle intercepts BC. If this is 40, this arc is 80. So for the whole circle, I've got 80, 150 together. That makes 230. So if I take 230 away from the 360, I'm left with 130 for CD. Number 7. this angle's 46, so I'm going to double that to get 92 for this arc. We have 158 and 92. That gives us 250. So if I take the 250 away from 360, I'm left with 110 for this arc. In number 8, 80 plus B has to be 180 because these angles are opposites. So B is 100. And 75 plus A would have to equal 180. So A is going to be 105. For number 9, this splits the circle in half. Since it splits the circle in half, I know there's 180 degrees on the top half and 180 degrees on the bottom half. So if I know this much is 32, I take that 32 away from 180 and I get 148. On the top half, I know 76, so I'm going to subtract the 76 and I get that this part is 104. So C is 104. Now, this angle here for B intercepts the 104, so B would be half of that. So B is going to be 52. Oops. A, going this way, intercepts the 76. So A would be half of the 76. A would be 38. And then lastly, D. D intersects the semicircle, so D has to be a right angle. D is 90 degrees. Alright, so that's your review for 10.4.